Today we're going to talk about what a proportional relationship looks like when we're looking at a proportional equation and how do we write that equation? What information do we need? So we already know that when we're given a table, if we do y divided by x for all of those columns and 0, 0 is part of that table, we have a proportional relationship. And then when we look at a graph, if we have a straight line that passes through the origin, we also have a proportional relationship. Let's examine what equations will look like for a proportional relationship. Remember, the equation for a proportional relationship or a direct variation can be written as y equals kx. This is very important. K represents the constant of proportionality. Or otherwise known as our unit rate. For example, in the equation y equals 5x, the coefficient 5 would represent the constant of proportionality. Or in other words, the unit rate. Just hammering that in there. A proportional equation does not have a constant. We're not adding anything to it. That's just a naked number. The way we can think about it is that it has a constant of 0. So y equals kx plus 0. But we don't really need to write that plus 0 business. So we just leave it alone. Let's look at number 1. We have this table here where we're describing the relationship between scoops in an ice cream cone and the price of the cone. And we need to find that constant of proportionality. We find the constant of proportionality by taking my y value divided by my x value. Or we've also talked about where when we're finding that unit rate, my x value equals 1. So I look at my y value and that tells me my unit rate. Either one is fine. Let's try out doing y divided by x. Why not? So we're going to try this point right here, the 2, 3.5. We're going to do 3.5. That's my y value divided by my x value. Divide top and bottom by 2. 2 divided by 2 is 1. So now I need to focus on 3.5 divided by 2. I need to change 3.5 to a mixed number, which makes that 7 halves. Change the division sign to multiplication and flip the second fraction, which makes that 7 fourths or 1 3/4. So see if you remember that tip about, looking in your table for when x equals 1 and whatever that y value is, that's your unit rate, would have saved us a little bit of a headache there. But the problem is that 1 3/4, we're talking about price. I never really talk about 1 3/4 dollars. I talk about 1 3/4, and in money, 3/4 would be 75 cents. So this would be $1.75. They were just extra tricky on us. My constant of proportionality would be $1.75. So it costs $1.75 per scoop. We use that information to write my equation. But remember, it's going to be y equals kx, meaning I'm going to take that $1.75 for each scoop and I'm going to multiply it. So 1 times 175, 2 times 275, 3 times 175, and I'll get each of these numbers. My equation would be y equals 175x. 1 7/75 x, or $1.75. We're going to use this equation to calculate the number of ice cream scoops we could buy with $28. We're talking about price here, and the variable we use to represent that would be y. I would go ahead and write down my equation, y equals 1 75/100 x. Then plug in my $28, I substitute it in, 1 75/100 x. I know to solve for x, I'm going to have to do that inverse operation, so I'm going to go ahead and divide by $1.75. 28 divided by 175, I type that in my calculator and I get x is equal to 16. Throw on my label there, and I could get 16 scoops for 28 bucks. That's a lot of ice cream. Problem number 2, we're given a graph that shows the relationship between the numbers minutes passed and the numbers of miles driven. We're asked to find the constant of proportionality from the graph. Remember, we could find 1 comma r just like we found in the table. We looked for where x was 1, and then whatever y value was, that was our unit rate. We can do the same thing in the graph. We go over to 1 and then we look up to see what our point is, and that will tell us our constant of proportionality or our unit rate. But in this case, they weren't that nice to us. We can take any of these points here and do y divided by x to figure out what our unit rate is. I'm going to go ahead and do 10 comma 5. Remember, that's x and that's y. To find my unit rate or my constant of proportionality, I always do my y divided by x, where y is my miles, number of miles driven, and x is minutes. So remember to put those labels in, because that's going to help us explain what it means. So y would be number of miles, and x is minutes. Now time for plugging in the numbers. My y value in this ordered pair I chose was 5. My x value was 10. Divide numerator and denominator by my denominator to get my unit rate. 5 divided by 10 is 1/2 miles per 1 minute. It means that I'm going to travel half a mile every minute. I'm going to use that equation. So this is my constant. My k value here is half a mile per minute. And I can just write it as that. And when I put it in my equation, it'll be y equals half x. We're going to calculate, using the equation, the number of miles we would have driven in 75 minutes. Calling back on my graph, minutes is talking about my x value. Write my equation, y equals half x. Plug in 75 for x, and then half of 75 would be 37.5, but I need to tack on my unit. Y is talking about my miles. The answer would be 37.5 miles driven in 75 minutes, so it's 37.5 miles. Question 3 is asking us to identify which equations below are part of a proportional relationship. You can find proportional equations by making sure that they are in the form y equals kx. There's no addition, no subtraction, anything like that. I'm going to go ahead and let you figure out which ones they are. Okay, these are the only 4 proportional equations that exist in this example. B is not one because of that +2. That's not one because it has that 9 minus. This one has -10, and that one's adding 6. So it just is straight up multiplication by the same constant. That does it for today's video.